we are starting elements, compounds, and mixtures. So hopefully you have discussed this. Basically, this is a very basic topic. Okay, so substance, you can say, is a general term. Okay, substance is a general term which is used for element, compound, or mixture. Like you can say that we are going to classify a substance into three categories: element, then compound, and then mixture. Element, then compound, and then mixture, right? So first of all, element. You can say first of all, element. Element. So do you have an idea like what the element is? Yes.
An element, an element, an
Mm-hmm.
element is a material where all the atoms are the same, like the molecules are the same.
Yes, exactly. Basically, the substance, the substance which is made, the substance which is made, the substance which is made from only one type of atom. Only one type of atom. Okay, the substance which is made from only one type of atom. Like let's suppose you can say that I have this sodium. I have this sodium, let's suppose a piece of sodium in which I have different, you can say, in which I have atoms which would be the same.
Yeah.
Just like that. Yes. So basically, all atoms are the same. All atoms are the same. So this is called an element. Let's suppose you have gold. So in gold, you will see the same type of atoms. And if you can see the copper, chromium, nickel, hydrogen, oxygen, fluorine, neon. So these all are elements in which you will see the same type of atoms. Elements can be represented by, elements can be represented by, you can say, symbol. Like this is an
Okay.
element that is sodium, that is sodium, whose symbol is Na. And let's suppose if you have magnesium, if you have magnesium, so the symbol for magnesium is Mg. And let's suppose this is hydrogen, so the symbol for hydrogen is H. But this is not necessary that if you have the name of a particular element, so whose symbol would be starting from the first letter. This is not mandatory. So let me give you example. We have potassium. We have potassium. Can you tell me the states? Can you tell me the symbol for potassium? Yes.
Symbol for potassium. The symbol for potassium will be K.
Is K, exactly. So this is something different. It should be, it should have the state, like it should have the symbol that is P, but in fact this is K, not P. Same goes with, same goes with gold. Can you tell me the symbol for gold? So you would say AU. You would say AU. And then we have iron. We have iron. It should have it should have the symbol that is I, but in fact this is Fe. So I mean to say that elements are represented by a symbol. Like if you can see the periodic table, in which you will see different elements that are arranged in order of their proton number. Hydrogen, then helium, then He, then Li, then Be, then B, then C, then N, then O, then F, then Ne, then Na, then Mg, then Al, like a lot of elements you would see with their samples, okay? And
Yeah.
elements are the simple ones. You cannot break it out into you can say chemically. They are not chemically broken down. That's not possible because they contain the same type of atoms. So let's suppose I have broken down the piece of magnesium. So what I would be getting, you will say magnesium. So this is not a chemical reaction. So in short, I can say that they are you can say unbreakable. Chemically you cannot break them out, okay, but physically you can break them. Like if you have a piece of sodium, so you can break into smaller pieces. If you have a piece of copper, so you can break into smaller pieces. So physical breakdown is possible for the elements, but the chemical breakdown of the elements are not possible. Are you getting my point?
Yeah.
Let's suppose this is let's suppose this is gold. This is gold. So I'm going to break it down physically. So I would be getting this.
Okay.
So
Wait, what do you mean by physically?
like let's suppose mm, I'm going to hit, you can say, a piece of gold, a piece of copper, a piece of magnesium, or a piece of iron. So it can break down into the smaller pieces. It can break down into smaller pieces. So it's still this is gold. Still this is gold. Still this is gold. Let's suppose in a chemical reaction, if you have calcium carbonate and you have broken down into calcium oxide and carbon dioxide, so this is one piece, and this is the broken form of calcium carbonate, in which you have two pieces. So this is something different as compared to this. This is something different. This is a chemical reaction. When in a chemical reaction, when something breaks down, so they form a new compound. But in this case, if you are going to break down the gold, so you will not be getting any new product. So I can say that elements cannot be in broken down chemically. Basically they can be broken down physically into smaller pieces, but still there is no any new product. Still this is gold. Initially this was gold, but after breaking down this is also a gold. This is called the physical breakdown. Are you getting my point? Yes.
Yeah. Yeah.
Okay. Okay. Then we have uh, compound. Then we have compound. Then we have compound. Yes. Can you tell me what is compound?
The compound is a mixture of two elements.
The compound is mixture of two
No,
elements.
no, it's not a mixture. It's like two element molecules together.
Basically, a compound is a substance. The compound is a substance made from two or more elements. Two or more elements that have
Mm-hmm.
that have chemically that have chemically combined.
Mm-hmm.
Chemically combined means that they cannot be separated easily. They cannot be separated easily. And let's suppose I have you can say this sodium that is a metal, and I have this chlorine gas. The color of chlorine gas is greenish yellow color, or I can say that the pale green color. Pale green color. So when they are going to react with each other, so they would be forming sodium chloride. This is this is a white solid. This is a white solid. This is a pale green gas. Pale green gas. This is silvery white solid. This is silvery white, silvery white solid. When they are going to combine with each other, they would be producing a new product whose color is changed, okay, and whose state is something different. This was a gas, but the product is having a solid state. I mean to say that when the two or more elements are going to react with each other chemically, so they would be forming a new product. So basically this is a chemical reaction. This is a chemical reaction in which you are going to mix two or more. It may be three. This is a chemical reaction in which you have only two reactants. It may be three, it may be four. But when they would be forming a product, you can see everything is different. You will not see any sodium in it. You will not see any chlorine in it. This is the very new compound. Okay. So this is called compound, right? So it cannot be separated easily. Like if you want, like let's suppose if you are willing to break down this sodium chloride and into the sodium metal and the chlorine gas. So this is quite difficult. On the other hand, if you have a mixture, so you can separate them easily, because it is easy to separate the mixture, because in a mixture this is not a chemical reaction, they are just physically combined. But in a chemical reaction they are chemically combined, they have made a bond with each other. Okay, so we would be discussing like what the bonding is, but right now I can say that this is a chemical reaction in which the new product is formed as a result of sodium and chlorine. We have a lot of chemical reactions in which we would see how the compounds are going to be formed. Let's suppose you can say that um, magnesium when reacts with H2SO4, so they produce MgSO4 and hydrogen gas. This is also a compound. This is also a compound which is formed by the reaction of this magnesium with sulfuric acid. This is also a chemical reaction. Remember, in a chemical reaction, mixture will never form. Mixture will never form. Okay, in any chemical reaction, mixture will never form. Okay, always the compound is going to form. Are you getting my point?
Okay.
Yes. So basically when we are going to form a compound, so you have to show the equation how this compound is going to be formed. So we can express the preparation of compound in two ways. Number one, you can express in a word equation, and you can express, you can say in the form of the formula. Let's suppose I can write down this. I can write down this as, you can say, I can write down this as when sodium reacts with chlorine gas to produce sodium chloride. This is called a word equation, and this is called a symbolic equation in which we have used symbols and different formulae. Remember, elements are represented by a symbol, but compounds are represented by a chemical formula. Remember, there is a difference. Compounds are represented by a chemical formula, and elements are represented by a symbol. Okay.
Okay.
So this is the word equation, and we can also convert this word equation into the symbolic equation, and also in that equation we would be having different chemical formulae. So let's suppose you can say that breakdown of means to say that thermal decomposition means that I'm going to break down something else. I'm going to break down something else in the presence of high temperature. So the thermal decomposition of the breakdown of calcium carbonate
Okay.
into calcium oxide and carbon dioxide. Can you convert this word equation into the symbolic, or like symbolic equation in which you would be having a chemical formula as well?
So calcium carbonate into calcium oxide and calcium dioxide.
Hmm.
So calcium carbonate, which is, let me just wait 1 second, let me get the periodic table. CaCO,
CaCO3
CaCO3, and then what's our other one? Calcium plus oxygen. I think it's plus oxygen. CO CO2. What?
hmm
Cl. Wait. I don't understand.
calcium oxide. This is Ca and oxide is O. So this is calcium oxide and this is
I know.
carbon dioxide.
But what is calcium carbonate reacting
C-
with?
CaCO3 is your calcium carbonate.
Yeah, but what is it reacting with?
So when it thermally decomposes, like you are going to provide heat to this calcium carbonate, so it would be breaking down into the smaller pieces, that is, you can say calcium oxide and carbon dioxide.
Okay.
Okay, then we have uh
Okay. Carbonate.
calcium copper 2 carbonate reacts with nitric acid to form magnesium nitrate and water.
Okay.
Sorry, it's not magnesium nitrate, it's copper nitrate. Because in the reactant side, I have copper, not magnesium. It's copper nitrate and water and then carbon dioxide.
It will be
So for copper
C
2 carbonate, I can write Cu and then,
CO3.
okay, nice. Why not Cu2CO3? Why you are saying that it's only CuCO3? Why?
Because only I'm not sure.
Mhm.
There's only
Basically, copper, the valency for copper is +2. Okay, the charge for copper is +2 and the charge for carbonate is -2. Let's suppose this is the carbonate, this is -2, and then we have copper, and then we have copper, this is +2, and then we have copper, this is +2, then we have copper, this is +2. So when you are going to write down the formula for copper carbonate, just like that, copper and then carbonate, so they would be canceling each other. As a result, you will see there is no charge on any of the atom. This is copper carbonate, and then it's going to react with HNO3, that is the nitric acid, and then it can form copper nitrate. This is nitrate. NO3 is nitrate. This is -1, but the copper is +2. Whenever you are going to write down the formula for copper nitrate, just like that, this is +2 and nitrate is -1. So obviously they will not be canceling each other as the numbers are different. So what am I supposed to do? This number I would be writing over here, and this number I would be writing over here. So as a result, I can say that it should be NO32. It should be NO32 and it should be 1. I'm not supposed to write down 1. I'm not supposed to write down 1. So that's why the formula is copper nitrate is CuNO3 taken twice. And then I have water. Obviously, this is H2O and this is carbon dioxide, that is CO2. So this is the formula equation from the word equation. Are you getting my point?
yeah.
Good. Okay, now if you have, let's suppose, um, iron, iron plus hydrochloric acid, iron plus hydrochloric acid, okay, and they are going to produce iron 2 chloride, iron 2 chloride, and and hydrogen gas. Yes. Yes. So what do you think? What should be the answer? Yes. It's
Fe
okay.
Cl
Cl. Cl or HCl?
HCl, sorry, HCl.
Yes. And then
Uh, it will be FeCl3.
it would be Fe
Cl
Cl.
uh 3, I think.
They have told you the charge of iron. They have
Which is
told you the charge of iron.
it's 2.
It's 2. So that this should be FeCl2. And then this is H2.
Okay.
Okay?
Okay.
Yes. Then the difficult one,
Okay.
see this. Sulfuric acid produces magnesium sulfate and then hydrogen gas. Yes. So you are saying this is MgOH2. Can you elaborate why this is OH2? Why not 3? Why not 1?
Because hydrogen has two, and oh wait, no, it's not. It's just MgOH.
You're right. This is MgOH2. But how?
Because of the hydrogen. Hydrogen is H2.
No, no.
So why is it?
So can you tell me the group number for magnesium?
Oh, two.
Group number for magnesium is 2. So the charge of magnesium is 2. So I'm writing down the charge of Mg over here, and the charge for OH is 1. I'm not supposed to write any number over here. And then sulfuric acid is H2SO4. Then what am I supposed to write?
Um, I'm not really sure, sorry. I'm not sure. I'm not sure what to write. Yes. Magnesium sulfate.
Magnesium sulfate, that is H2SO4, then hydrogen gas. Mg is plus 2, SO4 is minus 2. They would be canceling each other. That's why I'm not writing any number in the subscript of Mg and SO4. Okay?
Okay.
Okay, done.
Yeah.
Okay.
Okay.
So now you are supposed to make a word equation. Now you are supposed to make a word equation after looking at the formula equation.
Okay. I'm supposed to make a standardized equation? A what, sorry?
I'm writing it down.
Oh,
Can you tell me the word equation after looking at this formula equation?
a word equation. Uh, zinc plus copper nitrate, I think. Yeah.
Hmm?
Zinc plus copper nitrate equals zinc nitrate plus copper. It's a displacement reaction. Is that correct?
So yes, you told me that zinc, and then
Copper
it's
nitrate.
going to react with copper nitrate. Okay, then
It will become zinc nitrate plus copper, which is a displacement.
exactly. Yes, is going to form zinc nitrate and copper. Is going to form zinc nitrate and copper.
Because
Okay,
zinc is
is
more,
going to form zinc nitrate and copper.
is it because zinc's
Yes,
more reactive than copper and it displaces it, right?
basically this is the displacement reaction in which the zinc is more reactive than copper. We would be discussing this in the reactivity series, how the more reactive elements are going to displace the less reactive elements. Okay.
Okay.
Yes. See the last equation.
Okay. Do I convert it to formula? What? Wait, what do I do to it?
What's the formula for sodium carbonate?
First, the formula for sodium carbonate, which is NaCO3 plus uh,
And then what about
uh,
dilute sulfuric acid?
dilute sulfuric acid. Um, Basically, it will be. I don't know how. Wait, what do you mean by
This
dilute?
is simple H2SO4.
Okay. Um,
This is simple H2SO4, and then they are going to form sodium sulfate, that is Na2SO4. That's going to form sodium sulfate, that is Na2SO4, and then carbon dioxide, and then carbon dioxide and water are easy, but you are supposed to first indicate and mention that what's the sodium sulfate, in which there is sodium and there is sulfate. You know the valency of the sulfate, the charge of the sulfate is -2. That's
wait, 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 wait. Can
why
I go with a cup
I
of water? I'm
have
sorry.
written this